All right, let's dive deep into quasars today.
Quasars.
Yeah, they've been in the news a lot lately with all those Hubble discoveries.
Oh, yeah, for sure. Those are always fascinating.
So let's start with the basics.
Okay, sounds good.
For anyone who may not know, what exactly is a quasar?
Well, imagine like the brightest, most powerful thing you can think of.
Like a supernova.
Even brighter. Quasars are basically like giant cosmic lighthouses powered by these supermassive black holes.
Black holes. I thought nothing could escape those, not even light.
You're right, light can't escape from the black hole itself.
Right.
But it's the stuff falling into the black hole that creates the incredible light show.
Oh, okay. So stuff falling in makes the light, not the black hole itself.
Exactly. Imagine like a whirlpool, but instead of water, it's gas and dust spiraling into this massive black hole.
Okay, so as this stuff gets pulled in, it gets heated up and starts glowing.
Yeah, it gets squeezed and heated to millions of degrees, blasting out insane amounts of light and radiation.
Wow, that's intense. And I guess that's why we can see quasars from billions of light years away.
Yep, they're so luminous they outshine entire galaxies.
And speaking of seeing them, we're focusing on a specific quasar today, right?
Yes, 3C273, the first quasar ever discovered back in 1963.
1963. That's like before.
Yeah, quite a while ago. And what makes this one even more special
Okay.
is that you can actually see it with a backyard telescope.
No way,
Very
really?
rare.
Something billions of light years away?
It's about 2.5 billion light years away, to be exact.
Wow, 2.5 billion. That's mind-boggling. We're looking at light that left that quasar before humans even walked the Earth.
It really puts things into perspective.
It does. So we've got this unbelievably bright object powered by a supermassive black hole gobbling up matter.
Right.
And it's shining brighter than entire galaxies across billions of light years.
That's a quasar in a nutshell.
So how much energy are we talking about here? Like, how much brighter is a quasar compared to, say, our sun?
Well, the sun is pretty impressive on its own.
Oh, for sure.
But 3C273 shines with a brilliance of trillions of suns.
Trillions. Okay, I need a moment to wrap my head around that number.
It's hard to even fathom that kind of energy.
It really is. And to think, all that power comes from a black hole.
A supermassive one at that.
How supermassive are we talking?
This one is nearly 900 million times the mass of our sun.
900 million times. That's just, I can't even.
It's mind-blowing for sure.
Okay, so we've got this gargantuan black hole, matter spiraling in and getting superheated, blasting out light across the universe.
Yeah, that's the picture.
But it's funny because before quasars were discovered, some scientists imagined the opposite of black holes.
Oh yeah, like white holes.
Yep, white holes spewing out matter into the universe instead of sucking it in.
It's fascinating how our understanding evolves.
It is. Like that white hole idea from Sir James Jeans back in 1929.
1929. That seems like a lifetime ago in terms of scientific progress.
Absolutely. But it shows how we try to make sense of things with the knowledge we have at the time.
And then new observations come along and challenge those ideas, leading to new discoveries and a deeper understanding.
Like quasars. They basically threw that white hole idea right out the window.
They did indeed.
And a lot of that progress is thanks to technology like the Hubble Telescope.
Oh, absolutely. Hubble has been instrumental in revolutionizing our view of the universe.
It's given us these stunning images of 3C273.
And revealed some really weird structures around it.
Weird in what way?
Well, they're these filaments and lobes, like cosmic tendrils reaching out from the quasar.
Tendrils. Okay, now I'm picturing something out of a science fiction movie.
And then there's this one really strange L-shaped structure.
An L shape. What could that possibly be?
That's what scientists are trying to figure out. One theory is that some of these structures, particularly the L shape,
What?
might be remnants of smaller galaxies being pulled apart by 3C273's gravity.
Like the quasar is gobbling up entire galaxies.
That's not exactly gobbling them up whole, more like stretching and tearing them apart over millions of years.
Okay, so it's more like a cosmic demolition derby than a quick snack.
A very slow and messy demolition derby.
It's amazing to think about the scale of these events. Galaxies colliding, black holes feasting. It's cosmic drama on a grand scale.
It really puts our own little corner of the universe into perspective.
It does. But how is Hubble even able to see those details around 3C273? I mean, the quasar itself is incredibly bright.
It's like trying to see a firefly next to a spotlight, right?
Exactly. So how do they do it?
They use a clever trick called coronagraphy.
Coronagraphy, that sounds complicated.
It's actually a pretty simple concept.
Okay.
They basically block out the light from the quasar itself using a special instrument on Hubble called STIS.
So it's like creating an artificial eclipse.
Yeah, exactly. By blocking the glare, they can see those much fainter details around the quasar.
That's brilliant. So it's like using a shield to see what's hiding behind the light.
A very precise and sophisticated shield.
And this technique isn't just used for quasars, is it?
No, it's also used to study things like dusty disks around young stars, where planets are forming.
So by blocking out the light from the star, they can see the faint glow of the dust and maybe even spot planets.
Exactly. It's an incredibly versatile technique.
It's amazing how one method can be used to study objects both near and far, from planets forming around stars to quasars billions of light years away.
It's a testament to the ingenuity of scientists and the power of human curiosity.
It really is. But speaking of quasars, there's one more thing about 3C273 that I find just mind-blowing.
What's that?
That jet shooting out from it.
Yes, the jet.
It stretches for 300,000 light years and moves at nearly the speed of light.
300,000 light years. That's about 3 times the width of our entire Milky Way galaxy.
Yeah, it's all being blasted out from the area around that supermassive black hole.
It's like a cosmic fire hose spewing out matter and energy at incredible speeds.
It's hard to even wrap my head around the scale and power of it.
And what's even more fascinating
Okay.
is that by studying Hubble images taken over 22 years,
22 years, wow.
scientists have discovered that this jet is actually speeding up as it moves further away from the black hole.
Right, speeding you pee. But wouldn't it slow down as it gets further away from the source of energy?
That's what we would expect.
Right.
But this jet is defying expectations.
So what's going on? How is that even possible?
That's the million-dollar question. It suggests that there are forces at play that we don't fully understand yet.
So it's not just a cool spectacle, it's actually challenging our fundamental knowledge of black holes and these powerful jets.
It's a reminder that we still have so much to learn about the universe.
It really is. And this is just one quasar.
Right. There are millions of quasars out there, scattered across the observable universe.
Millions. So what can we learn from all these other quasars? Like, what's the bigger picture here?
Well, for one thing, they act as cosmic spotlights, allowing us to study the early universe.
The early universe. How's that possible?
Because light takes time to travel those vast cosmic distances, when we observe a quasar billions of light years away, we're seeing it as it was billions of years ago.
Oh, I see. So it's like looking back in time.
Exactly. And it turns out that quasars were much more common in the early universe.
Really? Why is that?
Well, back then, galaxies were closer together and collisions were more frequent.
Oh, right. Like those cosmic demolition derbies we talked about.
Those collisions fueled the supermassive black holes at the heart of quasars.
So these quasars are like little time capsules, showing us a period when the universe was a much wilder place, with galaxies constantly smashing into each other.
It was a very dynamic and active time in the universe's history.
It's incredible to think that we can get a glimpse into that chaotic period just by studying these distant quasars.
It's like having a front row seat to the universe's most epic demolition derby.
I love that analogy. But it's more than just a show, right? What else can we learn from studying these quasars?
Well, they can also help us refine our models of galaxy formation and evolution.
So it's not just a snapshot of the past, but it's actually helping us understand how we got to the universe we see today.
Exactly. Our early understanding was that galaxies grew slowly and steadily, accumulating gas and dust over time.
Like a slow and steady buildup.
Right, but the sheer number and intensity of quasars in the early universe paint a different picture.
Okay, how so?
It suggests that galactic mergers and interactions played a far more significant role in shaping galaxies.
So those cosmic demolition derbies, they weren't just destruction, they were also construction projects, smashing things together to build bigger and more complex galaxies like our own Milky Way.
Precisely. Those collisions weren't just chaotic events. They were essential for building the large-scale structures of the universe we see today. It really highlights how dynamic the early universe was compared to the relatively calmer universe we observe now.
It makes you wonder what those early galaxies looked like before being absorbed. Were they similar to the galaxies we see today, or were they completely different?
That's a question astronomers are actively trying to answer. While we can't travel back in time, we can analyze the light from these distant quasars. It's like a form of cosmic archaeology, piecing together the properties of these early galaxies from the faint light that reaches us billions of years later.
That's pretty amazing. And it makes me think about how far we've come in our understanding of the universe since the first quasar was discovered in 1963. Back then, it was this mysterious object that no one could explain. Now we're using them to study the very evolution of galaxies.
And we're still just scratching the surface. Every new observation from telescopes like Hubble and the James Webb Space Telescope brings more questions and pushes our understanding even further. Remember how we talk about Hubble needing to block out the intense light from 3C273 to see those fainter details?
Right, using that coronagraph technique to create an artificial eclipse.
Well, imagine going beyond simply blocking the light. Astronomers are developing even more advanced techniques using something called interferometry.
Interferometry, that sounds pretty high tech.
It is. It basically combines the light from multiple telescopes to create a virtual telescope with much higher resolution.
So instead of blocking out the light, they're using it to actually sharpen the image. That's brilliant.
Exactly. By combining the light waves from multiple telescopes, they can cancel out the bright light from the quasar and reveal those faint structures hidden in its glare. It's like using noise-canceling headphones, but for light.
So what kind of details are astronomers hoping to see with this? Will we be able to get a closer look at those galactic mergers?
One of the biggest goals is to directly image the accretion disk around the supermassive black hole. That's the swirling disk of material that's spiraling into the black hole.
So we're talking about seeing the very edge of a black hole, the point of no return where gravity takes over.
Yes, that would be a monumental achievement. Imagine the insights we could gain about the physics of black holes and how they interact with their surroundings by directly observing that region.
It's mind-boggling to think that we could one day see something that was once considered invisible and completely unobservable.
And it all started with a seemingly simple observation. A star-like object that turned out to be something far more extraordinary. It's a testament to the power of scientific curiosity and the endless wonders the universe holds.
It truly is. And it makes you wonder what other cosmic mysteries are hiding in plain sight, just waiting to be discovered if we could unravel the secrets of quasars just in the last few decades. Imagine what the future holds with these new technologies.
Absolutely. The universe is full of surprises, and there's no shortage of mysteries waiting to be unraveled. Who knows what incredible discoveries await us?
Well, I think it's time to bring our focus back to 3C273 and all the incredible things we've learned about it. Starting from a simple point of light visible from a backyard telescope, we've uncovered a story of immense energy, galactic collisions, and jets traveling at nearly the speed of light.
And remember that mysterious L-shaped structure we touched upon earlier. There's a lot more to that story than meets the eye. We'll dive into the latest research on that next.
So this L-shaped structure, what's the latest on that?
Well, it's a bit of a puzzle still, but the leading theory
Okay.
is that it's a region where gas and dust are kind of piling up.
Piling up?
Yeah, like a cosmic traffic jam
Oh, I see.
as they get pulled towards the black hole.
Makes sense. With all that gravity, things would get backed up.
Exactly. And as this material gets squeezed together,
Yeah.
it gets superheated, which could explain why we see it glowing in the Hubble images.
So it's not a single object, more like a zone of intense activity fueled by all this infalling matter.
Precisely. But what makes it even more interesting is that
Okay.
it seems to be connected to that jet.
You mean the one shooting out from the quasar?
The very same.
Yeah.
Remember how we talked about it stretching for 300,000 light years?
Yeah, and moving at nearly the speed of light.
Well, this L-shaped region appears to be right at the base of it.
Like the starting point of the jet.
Exactly. Almost like the nozzle of a cosmic fire hose.
Wow, that's an incredible image. So we're seeing the very point where this incredibly powerful jet is launched from the area around the black hole.
That's the idea. And by studying this region, we might finally be able to understand how these jets are formed.
It's amazing to think that something so abstract and so far away can tell us so much about the fundamental forces at play in the universe.
It really highlights how interconnected everything is, even across these vast cosmic distances.
And how much we still have to learn. I mean, we only discovered quasars like 60 years ago.
It's a blink of an eye in cosmic terms.
And now we're using them to probe the mysteries of black holes and the early universe.
And with new technologies like interferometry coming online,
Yeah, we talked about that earlier.
we're on the verge of even more groundbreaking discoveries.
It's both exciting and humbling to think about.
It is. There's so much out there that we don't know, but the journey of discovery is what makes it all so worthwhile.
Absolutely. Well, I think we've covered a lot of ground today, from those recent Hubble discoveries to the mind-boggling physics of quasars.
It's been quite a journey.
It has. So, as we wrap things up, what are some key takeaways you hope our listeners will remember about quasars?
Well, first and foremost, quasars are incredibly powerful objects powered by supermassive black holes.
Yeah, they're like the cosmic heavyweights.
They can outshine entire galaxies and launch jets of matter that travel for hundreds of thousands of light years.
And these jets, they're not just pretty to look at, they're actually telling us something about the physics of black holes and how they shape the galaxies around them.
And perhaps most importantly, quasars act as cosmic time machines, allowing us to peer back into the early universe and witness the chaotic dance of galaxy formation.
Yeah, it's incredible to think that we can study these objects billions of light years away and learn about a time when the universe was a very different place.
It's a reminder that our exploration of the universe is just beginning, and there's so much more out there waiting to be discovered.
Absolutely. Well, on that note, I want to thank you for joining me on this deep dive into the fascinating world of quasars.
It's my pleasure.
And to all our listeners out there, the next time you look up at the night sky, remember that you're seeing light that has traveled for billions of years to reach your eyes.
And who knows, maybe you'll even spot 3C273.
That bright beacon from the early universe shining down on us.
A reminder of the vastness and wonder of the cosmos.
So keep looking up, keep exploring, and until next time, happy stargazing.